For millennia, humans have been captivated by metal. For its strength, its malleability, its beauty. In architecture, advances in metallurgy allowed humankind to build higher, span greater distances more easily, and build faster, using far less effort and materials. Metals helped us to better protect our structures and the people and property inside from the forces of nature, and to create a more beautiful and enduring built environment. For millennia, humans have also explored the functional utility and artistry created when materials are woven together. First vines, branches, and leaves, and later natural fibers spun into yarns. This course will explore the modern architectural material created when these two ancient arts and sciences are skillfully combined. The material is woven metal, or as it's better known, woven wire mesh. Woven wire mesh's use in architectural applications continues to soar to new heights, owing to the material's many unique physical characteristics, including its impressive strength-to-weight ratio, remarkable durability, wide-ranging levels of translucency, environmental resourcefulness in material composition, and of course, its captivating metallic aesthetic, presented in nearly limitless patterns and textures. Today, woven wire mesh is used in wide-ranging applications, both for interiors and exteriors, and for both residential and commercial construction, as panel infill for railing systems, as a shading element, or a facade material, to create walls or barriers that can ventilate, or room dividers that help maintain sightlines and a sense of openness, as cladding for walls, and furniture, as a ceiling, for signage, and many, many more. Welcome to Designing with Pre-Crimped Woven Wire Mesh, sponsored by Banker Wire, your wire mesh authority. Successful completion of this course qualifies for 1 AIA CES HSW LU and/or 1 hour 0.1 IDCEC CEU. By the end of this course, you will 1. Significantly increase your knowledge and understanding of pre-crimped woven wire mesh, including how the material is manufactured successfully. 2. Be able to compare and contrast different crimping styles used in weaving wire, and learn common industry terminology used to describe or specify pre-crimped woven metal mesh products. 3. Gain a greater appreciation for the many functions pre-crimped woven metal mesh serves in architectural applications and the material's contribution to sustainable design. And 4, understand how to maximize your success in using pre-crimped woven wire mesh in architectural applications. Woven wire mesh is created by intersecting wires in an over and under fashion. The range of spacing and diameter combinations achievable is enormous. In terms of square openings alone, the effective range consists of 400 openings per inch, up to 6-inch clear opening. Let's begin with a few basics. Generally speaking, there are 2 types of woven wire mesh. Their differences have to do with the scale, that is, the spacing and diameter relationship of the wires and the strategy most effective in producing this scale. The first type is plain woven mesh. To get a better idea of this type, think of a metal insect screen, or the lint screen on a clothes dryer. Plain woven wire mesh is on the very fine end of the spectrum. The spacing and diameter of the wires in this range are too small to effectively form prior to weaving. Often using a soft or annealed wire, the loom simply places the wires in proximity to one another, The over-under sequence of the wires provide enough force to maintain the wire mesh structure. This mesh is made by weaving together small diameter wires on a loom. Since these wires are very thin and malleable, the weaving process itself causes the wires at intersections to bend around themselves. Plain woven wire mesh products are thin, fine, and flexible. They're easy to bend and shape and are often used for filtration processing. The second type of wire mesh, the type we'll cover in depth in this course, is pre-crimped woven wire mesh. Because of its strength, scale, and beauty, pre-crimped mesh is favored for use in a wide variety of architectural applications. Pre-crimped mesh is woven together on looms that are engineered and built specifically for the material's manufacture. However, before wire is placed into one of these specialty looms for weaving, it is first crimped into a specific shape. The crimps that are made in the wire form what are referred to as pockets, into which an intersecting wire nests in place. These crimps facilitate the weaving of stronger and larger diameter wires, and provide overall stability and consistency to the end product, especially mesh with wide spacing between wires. Unlike plain woven mesh, by pre-crimping wires before they are woven together, a manufacturer achieves a much higher degree of control over wire spacing. The pre-crimped pockets determine precisely where wires are to nest and lock into place. And it's this control which allows for far more intricate and interesting patterns. Over the years, various wire crimping styles were developed, originally to improve manufacturing efficiencies and to augment the function and performance of a mesh material, but more recently to create entirely new and imaginative patterns and aesthetics for architectural applications. To gain a better appreciation for what goes into making high-quality, pre-crimped woven wire mesh, let's look at how it's made, step by step. Pre-crimped woven wire mesh can be made from a variety of metals. Regardless of the metal chosen, the general process remains the same. Here, at the manufacturing facility, large spools of wire are received directly from a mill. It's important that these spools of metal are mill certified to ensure material composition and quality. If an entirely new mesh pattern is required, a mesh designer will engineer a new set of crimping wheels that will be used to crimp wire into a specific shape. These wheels are precision cut from a solid blank of steel using a CNC machine. There are hundreds of pairs of crimping wheels, with each pair capable of crimping wires in a distinct manner. Next, a pair of crimping wheels are installed onto a wire crimping machine. It's important that the operator align these wheels correctly, and that the wheels are precisely spaced from each other. Before a coil of wire is crimped, the operator creates a test sample from a short length of wire. Measurements are taken along the entire length of the test sample to be sure that both crimping wheels are operating properly across their entire circumferences. The peaks and valleys created in the crimped wire must be at the exact same spacing or interval, and the same height across the entire wire. This consistency is critical as hundreds of these wires will be woven together in an interlocking manner. Deviations in the crimping process could result in unwanted physical and visual characteristics of the mesh. Next, long runs of the pre-crimped wires are fed through a loom's heddle frames. These long lengths of wires are referred to as warp wires. The loom's heddle frames organize individual warp wires so that the over-under weaving process can begin. The operator cycles the heddle frames and inserts a wire across the width of the loom, one wire at a time. These wires are called weft wires. A sleigh positions the weft wire into the established crimps in the warp wires, and the process repeats itself to produce a panel of mesh. Quality checks throughout the weaving process are done by the operator to ensure dimension, squareness, and flatness. This is very important because deviations are amplified as weaving continues, which in turn can result in rejection of the product. When a specific length of mesh is woven, it's cut from the loom, set aside, and the loom continues to weave the next panel. The end result is a high-quality woven wire mesh product with a high degree of visual consistency across its entire length and width, and with every warp and weft wire consistently spaced and secured. Pre-crimped woven wire mesh comes in the widest variety of patterns, which is usually a primary concern for designers, as each provides a distinct texture and scale. These patterns can be relatively simple, a repeating rectangle, for example. Or patterns can be curvilinear in form. They can have a high degree of complexity, make the mesh appear light and delicate, or heavy and robust. Pre-crimped woven wire mesh manufacturers have hundreds of standard patterns with which to design. And at least one manufacturer has the ability to affordably create custom patterns to meet the vision of the designer. Of course, the function the mesh will serve in its architectural application is also a very important consideration. For example, will the mesh be purely decorative, providing form, texture, or reflectivity? Or will the mesh be tasked with doing more, such as shading sunlight, as a railing infill material, serving as a protective and decorative wall cladding, screening to provide ventilation with a degree of transparency in a space, or diffusing natural or artificial lighting? Later in the course, we'll look at a few of these applications. After pattern and function are considered, a designer has a wide variety of material and finish options to consider. Pre-crimped woven wire mesh is made from a wide variety of metals. It can be manufactured from a single type of metal or from multiple types. There are two important criteria to consider when selecting metal materials for use in an architectural application. The first is the aesthetic you wish to achieve. The metal or combination of metals chosen to weave a mesh product and how those metals are finished can dramatically change the appearance of a mesh product. The second consideration concerns the mesh's ability to resist corrosion, which depends upon where the mesh will be located, a building interior or exterior. Let's look at some of the metal materials commonly used to create pre-crimped woven wire mesh. The combination of characteristics of stainless steel wire, an alloy that includes chromium, nickel, and trace amounts of other elements, make it the most ideal metal for pre-crimped architectural mesh. Stainless steel's tensile strength, resiliency, and corrosion resistance make it the easiest with which to manufacture virtually any mesh pattern for virtually any architectural application. The chromium in stainless is responsible for the alloy's corrosion resistance. Its chromium content produces what's known as a passive layer, which is a protective oxide layer. The two most common types of stainless used in the manufacture of pre-crimped woven wire mesh is T304 and T316. The addition of 2% molybdenum makes T316 considerably more resistant to corrosion than T304. For this reason, T316 is the recommended alloy for coastal environments. The next group of metals are known collectively as living finish metals. This description refers to the fact that, if left untreated, the appearance of these metals dramatically changes over time as they interact with their environment and undergo oxidation. Even contact with the oils in our hands can affect the appearance of a living finish metal. Over time, the distinct oxide layer or patina that forms over the surface of a living finish metal serves as a corrosion-resistant barrier, making all living finish metals a good choice for exterior applications as well as interior. In their unoxidized state, living finish metals are bright and highly reflective. In order to maintain this appearance, they must be prevented from oxidizing. Applying a clear coat to the wire immediately after all tarnish has been chemically or mechanically removed helps maintain the wire's untarnished, bright appearance. There are also other coatings or chemicals that can be used to either speed up or slow down the formation of a patina. It should be emphasized that finishing living finish metals to a desired patina is an art form that should only be done by an experienced metal finisher. The living finish metals available are copper, brass, and bronze. Let's look at each. Pure C110 unoxidized copper wire is a bright or highly reflective salmon red color that contrasts beautifully when woven together with stainless. In exterior conditions with salt, moisture, and sunlight, copper transitions to shades of brown, then grays, and finally to a blue-green or gray-green patina. Brass wire is an alloy of copper and zinc. Varying the proportions of these two metals produces different colors of brass within the yellow to red spectrum in its untarnished state. Typical brass alloys used for pre-crimped mesh are C230, C260, and C270 brass. It tarnishes over time to a greenish-brown hue. Bronze is an alloy of copper and tin. C220, known as commercial bronze, is the most common alloy for manufacturing architectural pre-crimped woven mesh. This alloy has a bright caramel color, which forms a protective brown patina. Next is bare plain steel. While inexpensive, bare plain steel wire will rust under many conditions. To guard against rust, platings or powder coatings are options for finishing steel wire for interior applications. However, for exterior applications, powder-coated plain steel wire mesh will rust at wire intersections. The concern being that powder coating is unable to adequately cover the wire-on-wire construction of woven wire mesh. This is why, when powder coating for exterior applications, pre-galvanized steel wire is recommended. Pre-galvanized steel wire is coated with a thin layer of zinc during the wire drawing process prior to weaving. The thin protective zinc coating provides good corrosion protection at the metal-on-metal intersections where powder does not reach. Galfan wire is mild steel with a thick protective alloy coating of 95% zinc and 5% aluminum. Aluminum is added to the alloy coating to allow the alloy to be applied in a thicker layer without cracking off during the pre-crimping and weaving process. Galfan wire also has a self-healing ability. Minor scratches in the wire surface remain protected from corrosion as Galfan zinc reforms a protective patina over the scratch. Lastly is aluminum wire. Aluminum is highly resistant to atmospheric corrosion, is reasonably priced, has a variety of surface treatment options that make it a good candidate for many applications, and it's just 1/3 the weight of steel. Because aluminum has a low modulus of elasticity compared to steel, aluminum has higher degrees of deformation at equal loads. To maintain rigidity that may be required for a particular application, the diameter of aluminum must be increased. The most typical aluminum wire alloy used for architectural pre-crimped woven wire mesh is A1350, but A5056 and A6061 are also available. As you examine specifications for a particular pre-crimped mesh product, you'll see weight listed in pounds per square foot. This weight is based on that mesh product when made from plain steel. To calculate the weight of the mesh product made from a different metal, your mesh manufacturer provides a helpful conversion chart for the most popular metals. For example, to calculate the weight of this mesh product in copper, you would multiply the listed weight of 0.830 by the conversion percentage of 114.1 to get a weight of 0.947 pounds per square foot. Likewise, in aluminum, this product weighs just 34.7% of the listed weight, or 0.288 pounds per square foot. It's important for designers to understand some of the basic measurements and terminology that woven wire mesh manufacturers use, so that the manufacturer and designer are on the same page in the mesh selection process. Diameter simply measures the width of a wire. U.S. mesh manufacturers prefer that diameter be measured in decimals of an inch, as opposed to gauge, as confusion arises between gauges for ferrous metals versus non-ferrous metals versus sheet steel. By using decimals of an inch, this confusion is eliminated. Architectural pre-crimped woven wire mesh is most commonly manufactured in wire diameters ranging from 0.035 inch to 0.375 inch. Diameter, described in decimals of an inch, also allows designers to more easily describe non-round wire shapes. Keep in mind, architectural pre-crimped woven wire mesh is created not just with round wires. To stretch design possibilities further, you can also select wires of various shapes, including squares, fluted shapes, and wire that's been flattened through a rolling process. Clear opening measures the open space created between two adjacent wires. Wire spacing measures the frequency of wires in a mesh, just like the frequency of studs in wall construction, 16 inches on center in that case. Wire spacing is measured in one of two ways, but either should result in the same measurement. The first way is the on-center method called center to center, where a measurement is taken from the centers of two adjacent wires. The second method is called edge to edge, where a measurement is taken from the same side edge of two adjacent wires. The three basic measurements, wire spacing, diameter, and clear opening, can be expressed by a simple algebraic relationship. When any two of these measurements are known, the third can be easily calculated. It is very important to use the proper terminology when discussing wire spacing. When wire spacing is less than an inch, it is specified as the number of openings per lineal inch. For example, 2 mesh would have 2 openings every inch. 3 mesh, 3 openings per inch, and so on. When wire spacing is greater than 1 inch, it is now specified as a measurement or inch mesh. For example, 1-inch mesh has a 1-inch measurement from the center of each wire. 2-inch mesh is 2 inches from center to center, and so on. Be careful not to confuse the two forms of measurement. 2-inch mesh is vastly different from 2 mesh. Aspect ratio for rectangular mesh patterns works the same as television aspect ratios. With television, the old aspect ratio of standard definition TV was 4:3, more of a squarish picture, whereas the newer HD standard at 16:9 produces a much wider picture. Rectangular mesh can have open areas with a perfectly square 1:1 ratio to an extremely wide aspect ratio. The next important measurement is percent open area, or POA, as this calculation helps in comparing how much light or air will pass through a given mesh material. POA defines the ratio of open area to total screen area in a mesh product, and it's expressed as a percentage. For example, a mesh material with 40% open area will have 40 square inches of opening for every 100 square inches of mesh material. Because woven mesh is a three-dimensional material, the apparent visual open area will vary depending upon the angle at which the mesh is viewed. Therefore, published POA is calculated at a 90-degree angle of incidence to the plane of the mesh. Woven wire mesh can have POAs from 0% to more than 90%. Mesh to diameter ratio, or MD ratio for short, is equally useful to architects and designers as it is for manufacturers. Mesh to diameter ratio is wire spacing divided by wire diameter. Visually, the lower the MD ratio, the more heft the wire mesh will appear to have. Conversely, the higher the MD ratio, the less heft a mesh will appear to have. For woven wire mesh manufacturers, MD ratio is calculated to help determine the optimal wire crimp style to use to maximize both quality and manufacturing efficiency. Now let's explore some crimp styles that are used to create woven wire mesh. These crimp styles are the basic building blocks for manufacturing every pre-crimped woven wire mesh product. Crimp styles can be combined and modified in myriad ways to produce endless varieties of geometries and textures. Plain crimp is the simplest crimp style. It creates a repeating, smooth, rounded, over-under shape in a wire. With plain crimp mesh, both warp and weft wires are pre-crimped in this manner, then woven together to intersect at every available pocket. Plain crimp is most common when mesh to diameter ratios are 4 or less. The plain crimp style produces a smooth and subtle mesh pattern. Lock crimp is a more modern and versatile style than plain crimp. Unlike plain crimp, lock crimp is characterized by straight sections of wire that are connected through weaving by a well-defined bump at the wire intersections. Lock crimp yields mesh with superb dimensional stability. It produces a more textured appearance than plain crimp that some designers find more visually appealing. Lock crimp works well at MD ratios of 4 and greater. Flat top crimp is a modified version of lock crimp. The difference is that all the crimps are offset to one side of the mesh. This results in a smooth, flat plane on one side of the mesh. To produce this shape, on the reverse side of flat top mesh, the crimp bumps are twice the height of the bumps required for lock crimp. Intercrimp is simply a plain crimp style, except that wire intersections only occur at every third, fifth, or seventh crimp. Intercrimp mesh provides an interesting zigzag look. This type of weave is best suited for MD ratios of 8 or more. Triple shoot crimp is a style that's generally used in conjunction with another crimp style. It consists of long sections of straight wire interrupted by groupings of 3 plain crimp pockets. The resulting material has a very wide aspect ratio. A variation of triple shoot is rigid cable. Instead of 3 closely spaced wires with small open space between, rigid cable uses 2, 3, or 4 wires tightly positioned in a cluster with no open space between. The tightly clustered wires provide the look of a flexible mesh product that uses cables woven across wires. However, it is used where a rigid mesh is a desired characteristic. Helix crimp is a new style that departs from the wire mesh industry's traditional square, rectangular, and diamond geometries. With helix crimp, circular-shaped openings are created with intersecting helical-shaped wires. The smooth lines created by the spiral-shaped wires give this mesh a softer and more tranquil look and feel. Helix crimp can be combined with any other fundamental crimp style, creating unique woven wire mesh patterns. Twill crimp produces a low mesh-to-diameter ratio, but without the need to form wire beyond its physical limitations. To create a twill mesh pattern, 4 independent heddle frames on a loom produce complex wire positioning to create a wide variety of parallel diagonal pattern configurations. Pre-crimping a twill-style mesh allows complete control of the unique visual detail, emphasizing the herringbone pattern in a large-scale woven wire mesh. Before we move on to look at architectural applications for architectural pre-crimped woven wire mesh, a final important consideration for architects and designers is product cost. Unlike other building products, architectural mesh products widely range in cost, as low as $1 per square foot to as high as $65 per square foot. This wide range makes pre-crimped woven wire mesh particularly attractive as it allows for a project's specification, with the assistance of your mesh manufacturer, to be dialed in to balance a project's aesthetic, function, and budget requirements. There are many variables that affect the cost of a given mesh product. However, these are the 2 primary drivers. First is material cost. The weight of the product per square foot and the cost of the raw material used is what defines the overall material cost of the woven wire mesh. Steel is the least expensive, whereas living finish metals like copper, brass, and bronze are more expensive. Second is labor. The density and complexity of the woven wire mesh pattern translates into the amount of labor needed and the speed at which the pattern is manufactured. For example, a large and open mesh pattern will require less labor than that of a tighter, opaque pattern. Imaginative architects and designers working in conjunction with talented metal fabricators have produced many outstanding woven wire mesh installations. Let's now explore some examples to see how the material is being used today and benefits that architects and designers are leveraging from woven wire mesh. When it comes to architectural applications, the material's most prevalent use is for railing infill. It's a preferred material for this application owing to its strength, durability, varying transparencies, and wide range of aesthetic possibilities. Parking garages are another common structure where woven wire mesh is used for its ability to ventilate, shade, provide security, and maintain views. Fences and enclosures are also created from pre-crimped woven wire mesh to enclose stairwells or create secure areas. Again, the decorative nature of the mesh, along with its ability to maintain ventilation and views, make it ideal for these applications. Because of its superior durability compared to wood or sheet metals, another popular use for woven wire mesh is wall cladding, especially walls that are located in high traffic areas. The material is also popular for millwork and always provides a high-end look. Mesh ceilings and canopies are other popular applications. As a ceiling, the mesh can reflect uplighting beautifully or diffuse lighting located above the mesh. As an exterior canopy, the mesh can provide comfortable shading. Architects and designers are also using mesh to create elegant space dividers while maintaining views and airflow. When used in displays, the woven mesh can reflect the quality of the merchandise it surrounds. Sign makers leverage the unique characteristics of mesh as well. Even artists are exploring possibilities with this unique material. When looking to integrate woven wire mesh into your project, the best place to start is by contacting a reputable manufacturer. One U.S. manufacturer provides free and expert consultation to architects and interior designers. This manufacturer provides a wealth of technical assistance, helps guide your selection of a woven wire mesh product that can match your visual intent and meet the specific performance requirements of your project, and can provide specifications and a budget analysis to ensure that your concept will be financially feasible. This manufacturer can also point you to highly experienced and expert woven wire mesh fabricators who can make your vision in mesh a reality. One of the best attributes of woven wire mesh and the systems that incorporate it is its intrinsic sustainability. Where many building product manufacturers make green claims that do not always prove sustainability, woven wire mesh simply is. This is because metals are a valuable commodity. As such, as long as they aren't fused with other non-metals such as foams or polymers, they are almost always recycled. Doing otherwise is like disposing of money in a landfill. The value of metal also extends to manufacturing. For example, all scrap produced from manufacturing is collected for recycling. Also, up to 80% of the content of the metals used to create woven wire mesh has already been recycled. This makes metal one of the only products with a life cycle that goes from cradle back to cradle, again and again and again. Assuming that woven wire mesh is specified correctly according to its environment, it will endure indefinitely. Plus, it requires very little to no maintenance. Another sustainable attribute for woven wire mesh in the U.S. is the fact that the best quality and least expensive mesh is, in fact, manufactured right here in the U.S., eliminating energy expenditures and CO2 emissions created when shipping materials across the world. More importantly, perhaps the biggest environmental benefit one can leverage from woven metal fabric is based upon how it is chosen to be used by you, to reduce solar heat gain, to improve ventilation, and to create healthier and more comfortable environments. This completes our professional continuing education course, Designing with Pre-Crimped Woven Wire Mesh. To receive credit, you must now take the online 10-question quiz and score 80% or higher. To take the quiz, you must be logged in and certify that you spent at least 1 hour viewing and reviewing course content. You may take the quiz as often as necessary to pass. Banker Wire, headquartered in Mukwonago, Wisconsin, is the global leader in pre-crimped woven wire mesh. To explore more architectural and design possibilities with Banker Woven Wire Mesh, please visit www.bankerwire.com today or call 1-800-523-6772. We look forward to working with you on your next project.